happens? These strands denature, they come apart, and the little primers that you put in there will sit right here and lay down the parameters of what you want to copy. Then this stuff called Taq polymerase. Taq polymerase will then start taking the nucleotides that you put in there and start forming the complementary strand. Then when those strands are ripped apart again, you make some new DNA and you've got now 2 strands. So the way the strands are made in this machine, exponentially. 2, 4, what's the next number? 8, then what? 16, 32, 64, 128. Not linear, exponential. So that being said, this is exactly how the thermocycler works. Here's what's important about Taq polymerase. We're heating this to 94 degrees. Then we're going to let it cool to about 65 degrees. Put the primers on. Let it cool to, or go up to 72 degrees so this can happen. And then we're going to bring it up to 94 again to split these. So it's called a thermocycler. 94, 65, 72. 94, 65, 72. On and on and on. That's why it's called a thermocycler. Do you agree that the temperatures in that thermocycler get to some pretty high temperatures, 94 degrees Celsius, right? Mm-hmm. This would be destroyed at 94 degrees. Why is it not destroyed? Because it's an enzyme that's taken out of organisms that live at geysers. Do you guys know what geysers are?
Hot,
Yes.
underwater.
Right, that spew up water like at Yellowstone National Park. There's bacteria that live at the mouths of these geysers, and the bacteria can survive under very, very high temperatures. So the bacteria is called Thermus aquaticus. So that's why this is called Taq polymerase. We use that enzyme from those organisms. So that's why you have to use Taq polymerase here. Can't use just a plain old DNA polymerase 3. That won't work. Here's the nucleotides that you bought to put in there. Here are the primers that you bought to put on there. And of course, you've got your original strand, right? So the 4 things. Number 1, number 2, number 3, and number 4. The 4 contents, or the 4 ingredients that you need to perform a successful polymerase chain reaction. Make sense? You know why these primers stick here? Because they're complementary to here. And how did they stick there? What's the fancy word?
Hybridized.
Hybridized there. And by the way, how do they stick there? It's because if this is an A, this yellow one would have to be a
T.
And if this was a G, this one would have to be a C. This is what we call